Hey everyone, welcome back to Chapter 4. We'll continue our discussion on forecasting. We're going to now specifically consider quantitative forecasting. So we'll consider some methods and also discuss how we can figure out how well or how accurate we are forecasting. So when we're discussing quantitative methods, we can apply these methods when we have a little bit more data, when things are kind of stable. So what that means is, existing products or current technology, things that have been, established, whether it's in hospitality or, any business, we can start to apply this sort of mathematical technique. So an example in your book is forecasting colored televisions, but of course we can use it to forecast hotel room sales or number of burgers we're going to sell in the future. Before we get into the actual techniques, we're just going to talk a little bit about time, okay? Just as we mentioned, different time horizons. When it comes to quantitative forecasting, it's important to understand that we're looking at it from a certain amount of time, but now we might be looking within a year, so it's weekly, monthly, and quarterly. Now, as we mentioned, we're going to use a lot of historical data. That data is, of course, the past, and we're going to use that data to sort of, predict the future. So it's a big assumption that we're making that past sales are going to hopefully replicate future sales. So there is an assumption there, and based on that assumption, we're going to apply this type of forecasting. Now, it's important to consider some components to our time series, and we'll talk about each one in just a moment. Okay. But why don't we look at a graph and maybe we can understand what we mean by some of these components. So this graph represents the actual demand of a product. Okay, that's what that squiggly line represents. And it also helps us identify some different components of demand. So over 4 years, we can see, first is the trend component. We can see there's an upward trend. Okay, see that moving upward. We also can have an idea that there's some sort of seasonal demand as well. It seems like somewhere in the middle of each year, it looks like that's where we have our peak demand as well. Okay, and we also recognize a little random variation here. So typically we see a pretty steady kind of up and down demand line here, but we notice here it drops a little bit lower than usual. Usually it would stay up here, right? So this is considered some sort of random variation. We don't see it again throughout the 4 years. So let's get into a little bit more detail on each component. So we talked about trends. Now, of course, when it comes to a trend, we need a lot of data to start recognizing that there is some sort of trend, whether it's upwards or downwards. So usually about three years is typically what the expectation is to start seeing some trends. Okay, and we'll talk more specifically about different examples throughout the course. Okay, but for now, just understand what we mean by a trend. Seasonal component. Well, particularly in hospitality, this is really quite relevant, of course, and I'm sure many of us are familiar with different types of seasons. We look at it maybe in terms of quarters, and of course, the weather has a lot to do with it. So we have a summer season. When we think about hospitality, we always think about usually it's a busier time for hotels, tourism, things of that nature. And of course, when we talk about a season, we're thinking about it throughout, 1 year. Okay. Now we mentioned quarters, but there's other ways to consider a season in a pattern. We might do it maybe a day of week that's really busy. So we think about, Friday night. Can be considered really busy within that week period. Okay, so that's what we also mean by seasonal, and it can vary as well. So that's seasonal. We also have cyclical component. Now this is similar to seasonal, except it's usually over a longer period of time, but you're still going to see sort of up and down. This is very common more in, for instance, the economy. You could see that recessions are known to have occurred in a cyclical manner, maybe 8 to 10 years or something like that. Reason why politics are important is if you have a 4-year term, depending on who's in charge, that can make an impact as well. So usually, again, as we mentioned, it's a longer period, so years, multiple years of duration, but also there's this associative relationship. Okay, so maybe inflation rates are going to affect the economy. It gets to the point where there might be a recession, or maybe, depending on who's in power, that also might affect the forecasting. So this is one way to forecast maybe a longer period of time. And as you can see here on our graph, we see that it's a longer period, but we still have that sort of up and down, almost seasonal-like pattern, just on a longer period. And we also mentioned the random component. Okay, so this, again, think of it as a sort of a blip or a one-off. Of course, COVID, that was quite an example of a random variation. And most importantly, when it comes to random, it's just the idea that it's really just not predictable. Okay, so there's no pattern to be expected. And this often happens, if there's, once in a while we might have really extreme weather, although unfortunately it's getting a little more common, but that's another example where you just can't predict something of that nature. Okay, so again, we can see that these are just random components, and there isn't really any rhyme or reason for it. So this, of course, is the hardest to forecast. So those are the different components. Let's talk now about the actual techniques. Okay, so there's 4 techniques that we'll be applying in this course. We'll start with the number 1, or the naive approach. Okay, naive approach is really very simple. Basically, we're assuming that the demand in the next period is based off of the demand from the most recent period. Okay, so if we're looking at it from a monthly point of view, we're going to assume, let's say we're going to sell our burgers. We're trying to predict or forecast the amount of burger sales in February. Well, we knew that January sales were 68, so we think February is also 68. So this is what we mean by a naive approach. And, it's very simple, so it means it's cost effective, easily to do. Okay, and, believe it or not, this is a very effective way to just get a good sort of foundational idea of what to expect. And this happens a lot. You could also think, well, if I'm trying to forecast what's going to happen for New Year's Eve, I could look at last year's New Year's Eve and get an idea. Okay, so it's a very common way to forecast, and you'll be doing this a lot when you're managing. So that's the first. Second is the moving average. There's a couple moving averages. We're talking with the most basic moving average. Okay, and this is helpful if demand is fairly steady over time. Okay, and we'll talk about some of the disadvantages in a moment, but we'll just talk about how to actually calculate the moving average. And basically, again, the reason why it's helpful if demand is steady over time, because basically what the average does is just, as the name suggests, it averages things out, it smooths things out. So you might have a really high period and really low period, and you're just going to kind of get the average. Okay. So what does it look like in terms of the formula? Basically, you're just going to add up all of the demand periods divided by the number of periods. So let's look at an example here. If we are, let's say it's the end of March and we're trying to forecast April sales. Well, if we use a moving average, and this is a 3-month moving average, we would take January, February, March, add them all together, and again we divide by the number of periods, which is 3. So we would forecast April to be about 11 2/3. Okay. So again, really just taking the average of the last 3 months. Now, as we mentioned, and we'll look at this a little bit more specifically in a second, but think about what happens, if, as you can see here, there is an increase in demand from 10 to 13, but really this moving average kind of smooths out that trend. So that's something that we should consider. Now, with that being said, we can use a weighted moving average, which is similar to the moving average, but now we're going to apply, the weight suggests some sort of priority. In other words, we're going to consider the data from the most recent periods to be more important, which also means that the data from the further back is less important. So in other words, that January month is not as important as that March month when we're predicting for April. Okay. Now, how do we actually calculate the weights? Well, this is where the sort of art of forecasting comes in. We are going to rely on some sort of qualitative experience forecasting to say, well, no, I think March is a more important month than February, and so on. So we'll talk about that later, but for now, just understand the formula here. Very similar to the moving average, but now we're including weights as well. Okay. Again, let's look at an example here. So we have that same example. And if you remember, the forecasted for April was about 11. Okay. But now what we're doing is we are deciding that March is more important. This number of actual sales is more important to consider than January. And the way that we do that mathematically is that we include a higher weight with it. So you can see the weight of March is about 3 times more important than the weight of January. And again, we see that because we're multiplying here. This is our weight for March by 3. February is also important, but not as important as March. So we have a weight of 2. And then finally here, we actually do have a weight, just not shown mathematically, but it's a weight of 1. So 1 times 10 is the 10 there, okay? So again, you can see that here, okay? I guess, yeah, it's more clear here. And again, what we're assuming in this case is that the most recent information or data is more important to consider. Now, what ends up happening, it is a bit better in terms of, if we compare our actual to our forecasted, right? So it's a little bit higher. So it is improving our forecasting. Now, it is improving, but again, overall, we'll talk about some of the challenges or the issues with using a moving average. Now, we discussed this one already. Okay, so that again, if we're taking an average over a number of periods, it's going to really smooth out the average, right? We discussed the idea that doesn't really recognize trends very well, right? Because again, we're taking that average, and it doesn't really matter if we had a really high season in March versus January. If we just do a moving average, it kind of averages it out. Now, of course, the weighted average helps a little bit, but it's still not quite there. We'll look at a chart to recognize that in just one moment. Another thing we haven't really discussed is that it does require a lot of data, right? Especially if you're doing a 3-month, or imagine if you do a 6-month average, you need 6 months of data and so forth. So one of the disadvantages of this type of forecasting, compare that to even naive forecasting where you only need the previous year or the previous period. This does require more data. So that's another disadvantage. Okay. Now, what we talked about is this idea that, again, doesn't recognize trends very well. Okay. And really what it ends up happening, and this is now basically we're just taking those data points and now plotting on a graph, but we can see is that, so again, the red is our moving average, right? That was the first forecasting technique we used. And then the green is the weighted moving average. Now you can see the green is a little bit closer to the actual sales, but both of them are really lagging behind. And that's what ends up usually happening with this type of moving average, because it's always taking the average of the previous months, which ends up not really responsive to what's actually happened. So if you think about it, it's about a couple of months behind. The pattern looks good, especially the weighted moving average. It's just really behind. So we need to kind of, move it back a little bit. So there's a big challenge with moving averages in that regard. So enter the final technique, which is exponential smoothing. Now this is also a weighted moving average, okay? But the weights are used a little bit differently. Okay, still the same kind of concept applies, which is using the most recent data. Okay, but the way we calculate is a little different, and we'll see that in just one moment. So in this case, what we need is what's called a smoothing constant, and this is typically represented by alpha. Okay, and this ranges from 0 to 1. And just similar to the weights, it's another example of that quantitative approach where you have to subjectively decide. So it's we're relying on some sort of experience or intuition to decide whether or not the right weight is applied. Okay. Now the advantage of this, in contrast to the moving average, is that it really requires very little data. Okay, very similar to the naive approach, where it only really requires last year's period. So let's take a look at the example here, at least with the formula. What we're going to be doing is we're going to take last year's period, okay, and then we're going to add that smoothing constant, and then we're going to use last year's actual demand, right? So we're taking the actual of last period, and we're going to subtract last period's forecast, okay? So just taking the difference. And again, don't worry too much about applying the numbers right now. We will get to that. But for now, just recognize the concept of it, okay? So you can see here what's interesting too is that we're using our actual numbers from the previous period. That's what that T-1 is, okay? So we're using last period. That's also the T-1, the forecasted, the actual. And then again, we're using the actual from forecasted from the previous period. Okay, so again, if just a little kind of definition of everything here. Okay, and remember that actual or that smoothing constant, okay, is from 0 to 1. And when you start using some numbers, you can see how that applies. So here's an example here. Let's say we want to predict the amount of sales for our Ford Mustangs. Okay, that's an example we have. So we have the predicted demand, we have the actual demand, and we have the smoothing constant. So let's put that in, smoothing constant. Let's put that into our formula here. Again, we have our predicted demand here. Then we have that smoothing constant, which is between 0 and 1, in which in this case it's 0.2. And then we simply take the difference between the actual minus the forecasted. So when we talk about predicted demand, that's basically what we mean by forecast. Okay, we're predicting that demand. So what ends up happening when you do the math, you get about 144 cars. Okay, so this is again another format that we can use, and you can see it's actually not requiring a lot of data, which is very helpful. This is why sometimes we like to use this method. Now, again, we talked about how the smoothing constant is subjectively chosen. Okay, usually they're within this range. Okay, and what ends up happening, yes, if the alpha increases, what ends up happening is that what we're saying and we're suggesting is that the older values become less significant. In fact, if you make the alpha 1, then there is no weight whatsoever. Okay. So just so you have an understanding of what happens when we change the constant, okay. So again, we have our actual demand here, okay. So if we made our constant 0.5, we can see here, this is our values here, okay. So just so we have some information here. If we have, if we expect the average to change, we would use a higher alpha. You can see there's actually more change when we're using higher alpha, okay? But if we're looking for something to smooth out a little bit more, we would use a low alpha. In other words, if it's a more stable pattern, then we would replicate a more stable pattern. Okay, so those are 4 techniques we can use. Let's just quickly discuss how we measure forecast accuracy. Okay, now, there's lots of ways to do it, but I just want you to understand that obviously, we don't want to just forecast and then let things happen and not reflect on whether or not we were successful in forecasting accurately. So, very often we're going to look at some sort of difference between our actual and the forecast that we made. So one example in your text is we can use what's called the mean absolute percent error. And basically what that means, again, is just trying to find the difference between how well we forecasted and really just putting it in a percent form. Okay, so what do we mean by this mathematically? Well, here is the formula here. Okay, and really, again, is you're just taking the difference, which is the actual minus the forecast. You're dividing it by the actual divided by the number of periods. Okay, and that's just going to give you a nice percent. So here is an example of using that MAPE to determine your forecast accuracy. So again, you can look at it from each quarter. So if we forecast is 175 and our actual is 180, then we would just take the difference, which is the 5, divided by the actual, the 180, and that gives us a forecast accuracy of 2.78. Okay, and again, if we wanted to do it all together, same concept applies, but we would use the sum of all of the periods. So once we can actually add up all of the actual or the maps of each quarter, get a sum of the errors, divide that by 8, and then we have the overall accuracy of the forecast. Okay. Now those are some of the techniques. We've talked about how we can compute forecast accuracy. We'll just talk briefly about forecasting in the service sector. And I will say this is probably the most challenging area to forecast. Okay. And really, it's just because there's just so much fluctuation and we need so much change in regards to being responsive. So, whether it has to be with, figuring out different holidays and events and how that actually impacts our business, it can be very challenging. Sometimes a long weekend might mean that we're very, very busy, or it might mean that we're actually not busy at all, right? So we really have to have both that qualitative and quantitative understanding. Okay, just to give you an example, and I'm sure some of you are kind of familiar with this, whether you're a guest or working. But look at the amount of demand, in a fast food restaurant. So you can see that and this is probably one of the reasons why you might see on your start times why you start at 12:15 and not 12 o'clock, and there's a lot of staggered starts, just because we want to try and be as precise as possible. And that's an example of how we're using our forecast to properly schedule. Okay, so it's really important. Excellent. So that's an idea of quantitative forecasting. We've discussed naive moving average, weighted moving average, and also exponential smoothing. And then we've computed our forecast accuracy. Thanks for watching, and we'll see you next time.